from India, and good evening to all of the guys who are joining us from US. Are all of you able to hear me? Great. Good morning, Satyanarayan. Good morning, Apurva. Great. So, great. Thank you. Thank you for confirming. Just another check. Is my voice loud and clear to everybody? Good evening, Priyank. I understand. Okay. That's great. That's great. So guys, it's 7 a.m. sharp India time. And this is, there are many people who have already joined by the time I started, and by this time, so I think within these some 10 or 15 seconds, uh, almost that many number of people have joined us. So I'm just trying to give it some time to settle it down. Is this okay if we just wait for another 1 minute? Let others also to join. Is this okay, guys? Great. Thank you. Yes, Apurva, I'm going to do that. So definitely about my background, definitely about it, but I'm just, waiting others also to join so that nobody should miss it. Okay, so I think time to get started. Uh, Still people are coming in, but still, we have the time foundation of 1 hour, so definitely, yes. Yeah, so getting started, guys, a very warm welcome again to all of you who have joined very recently in last 1 minute or so. So my name is Vishal Kumar, and I'm going to take this introductory session on big data processing with Spark and Scala. Before I proceed about it, uh, a little bit about myself. So I have overall 10 years plus experience in IT. IT, if you call it that way, I typically call it as software engineering. And when it comes to this side, the exposure from the technology side, uh, in big data world, I think I'm active since last almost now going to be 5 years, 4.5 years plus kind of thing. Uh, just like many people, my journey also started with Hadoop, though at that point of time Hadoop was not that mature as it is today. And typically, the transition from RDBMS world to non-RDBMS world, and it took some time to settle down. I've tried various things: native MapReduce, Hadoop streaming, and then Hive, Peg, etc. All of those stack. We had to do that, and then slowly move towards the other frameworks, like there's something called Storm, then Spark. Spark is something which we started very recently, I would say. But yes, we have started working on it. Apart from that, when it comes to the other kind of frameworks, be it Cassandra or be it a bit of MongoDB also, those are the things to which I have the exposure. When it comes to the domain side of it, so most of my exposure is in the retail domain and in finance domain. So that's primary exposure towards the domain side. There were some small projects which were from healthcare domain as well as in the telecom domain also. But again, they are quite insignificant as compared to the overall exposure from the other domain side. So that's, I think that's pretty much about myself. All right. So Apurva, I hope it's kind of quite clear. Definitely, Apurva. So just like you, there must be other people also who are having those questions. Probably we can take it after the class as well. So about my projects, the kind of projects which I have done, they are typically from the greenfield projects of big data, typically from Hadoop side. On Spark and all, right now, most of the industry is into the POC stages. So everybody have their own kind of setups. But when it comes to Hadoop, more mature technologies, right? When it comes to Hadoop, Cassandra, etc. So it's about greenfield projects as well as some migration projects also. So you have some legacy applications, and enterprises are kind of finding out that yes, they now need to move on because of either performance problems or because of the cost problems or something. So yes, you will find about those kind of projects. So I have the exposure towards greenfield projects as well as towards the migration projects. Hope it quite it explains things quite clearly. Right. Great. So let's just get started about it. So guys, the agenda or the objectives of this session are going to be one thing is, what is big data? So as many of you, I can realize, I can actually see some of you have already attended some of my earlier lectures or earlier classes, but yes, those people who don't have the idea about big data, it would be a very brief touch and go kind of a discussion on what exactly is big data. So before even jumping to Spark is just one of the ways through which you are tackling big data in a specific manner, right? So the first and that root question is, what exactly is big data? That is something which will kind of immediately touch it, and then we'll go back. Then the question would come, what exactly is Spark? So those people who have attended Hadoop classes earlier, they definitely would be aware that after, typically when we talk about big data, then we typically move towards what is Hadoop and key differentiators and all. But here, since the focus is going to be Spark, so the next point of discussion would be, what is Spark? We'll talk about its kind of capabilities and all, a brief about those capabilities in this section. And then the next question is about why Spark. So again, in big data world, Spark is not just the only solution for all of us to implement our solutions with. So why Spark? Those kind of important questions would be there. Then we'll talk a bit about Spark ecosystem. So the good thing, or I would say the key differentiator between Spark and other I would say other choices which are at your exposure, right, is the thing is that Spark is an ecosystem. It's not a kind of specialized solution itself. So more about it when we'll come to this part. And then there is a mysterious note about Scala. So as you, by now you would have already known that it's a course about big data analysis using Spark and Scala. So it's a bit note about Scala. Why Scala here, right? And that's it. But typically we don't end any of our sessions, be it introductory or be it our classes, without a bit of hands-on. So I've kept a very brief hello world kind of a thing for Spark, which is called Hello Spark, and we'll just see that. I mean, what it takes to run a very simplistic or minimalistic kind of a Spark interaction, and what exactly are the differences. I mean, especially those people who have attended Hadoop classes, they will immediately be able to relate what exactly is the difference when you when you try to run the very same kind of operation in Spark. So what happens from the performance side, right? So those are some of the things which we are going to discuss. Another thing, I can see since it is a session, of course, it's going to be a dialogue. I'm going to speak quite a lot, and definitely you guys are also having the questions which you anyway are putting in. Though there are a lot of people, I think they are in the excess of 150 plus and still increasing. So it is not really easy for me to answer all of your questions right away. So you have please, I please insist that all of you, put your questions on our Twitter handle, right, @edureka.in #ask@edureka, or you can put your questions on Facebook, just in case if your questions are not answered in this session. Okay, so our team, our dedicated team is sitting there to, answer the questions promptly. Okay, so that is just one note which I want to, convey. Though at the same time, I'm looking at the questions panel also. So just in case if there are some sort of, common questions which is being asked by 10 people, definitely is something which I gonna, address within it. Okay, great. Now, so coming to the point of what exactly is big data. Especially this particular slide would be quite familiar to the people who have attended our Hadoop course, but for those people who have not attended, or as I think it was Mukul, or there are some more people who are quite new, who are quite new to big data world. So it is about the simplest answer would be it's lots of data. Okay. Now this lots of data is something which is quite ambiguous. I would say if 3 years before, if you look back and from your RDBMS background and all that stuff, if your typical database instance used to be more than several GBs, let's say 3 GB database file size or something, right? Then your typical, your administrators and all used to say that, hey, you know what, you're dealing with a big data instance, right? You're dealing with quite a big data, database instance itself. So at that point of time, your the scale was at several GBs. That was the criteria, and we used to call it as kind of big data instance altogether. Today, in today's scenario, if we look at it, then typically we are in the range of several terabytes. And probably 3 years down the line, when somebody else would be taking this kind of session for a new technology and big data and all, probably the scale would be at least several petabytes or something. Though petabyte itself is a scale for the companies like Facebook and Google and all, right? But it's especially talking about the wide variety of those companies which are in the market. Typically terabyte itself is the kind of running scale right now. So overall point which I want to make is lots of data. This is kind of a moving target. Earlier it was in several GBs. Right now 2014 we are in several TBs. Probably going forward, the minimum definition for this would be at least several petabytes and all. So that would be the simplest definition. But again, so what I mean, is this the only volume thing? No, it is not just a volume. The thing which makes big data all the more challenging, all the more exciting is the kind of challenges which come along with it. One, volume, all of you can guess, no prizes for that, right? That your storage problem becomes a bit problem, you're problematic. The other problems which come with it is about the crunching part of the data, about the processing part of the data itself, right? You cannot really process several terabytes of data using a single monolithic big machine itself, right? Whatsoever big the machine is, right? Because vertical scalability has got a certain limit, right? So of course you have to move towards some new paradigms of programming itself, typically distributed programming, typically MapReduce, right? So something like that, right? So it becomes very, very difficult from the processing side itself. The third point is all about when you're talking about such a huge scale of data, such a huge volume of the data, right? This data volume is something which is not just only RDBMS data, or is not just a structured kind of a data, right? You're not really going to get terabytes of let's say Oracle tables data every day, No, this is not going to happen. You're going to get this huge volume of data in various data formats, and those various data formats, if you are very lucky, might be some Oracle or some RDBMS table data, might be some of the production logs, might be some of the clickstream data and things like that, right? So the other aspect of it is the variety of the data itself, right? And again, if you are talking about 1 terabyte data or more every day, we are talking at the scale of, we are talking about the third aspect of also, right? We are talking about velocity of the data as well, right? Velocity is typically the rate at which you are collecting the data, right? So 1 terabyte or more amount of data every day, of course you are talking about a huge data sinking kind of a scenario wherein you are absorbing so much amount of data within a very short span of time, right? So those are the kind of challenges. If I try to summarize it, one is these are typically called 3 V's of data, 3 V's of big data. One is the volume, then the other one is the velocity, right? Volume is the, right? It's all about how much data you are collecting. Velocity, at what rate you are collecting. Third, variety, the kind of, you have seen that, right? JSON data, XML data, RDBMS data, log data, things like that, right? So these are the typical kind of challenges, or I would say kind of pillars which are there, and they give you the challenges from the capture side, data capture side, data processing side, data sharing side, analysis side, and whatnot, right? So I hope, especially for the people who are completely new to the big data world, right, it would act as a very high level but good enough kind of primer about it, right? What is big data and what are the kind of challenges which come along with it, right guys? Now the point is, okay, before I proceed, there was this thing from one person who says, I hope I'm quite audible to everybody, right? Right? Am I audible to everybody? Great. So Santosh, seems like there was some problem at your end. Okay. Great. Sure. Thank you. Now, so the next point is, what exactly is Spark? So guys, again, in all of my discussion, most of the parallels would be from the Hadoop side. The reason being that I understand that many of you people have already attended Hadoop course, though many of you would not have even have attended also Hadoop course, okay? So I will keep both of the kind of audience in mind. So when it comes to Spark, if those people who are from Hadoop background, they can easily correlate that what exactly is Hadoop? Hadoop is actually a distributed processing system, right? Spark is no different. Spark is also a general purpose distributed, or this word which you are seeing right now, cluster or distributed in-memory computing system. The difference between Hadoop and Spark is that Spark is more towards the side of in-memory computing system. It is not the the one which is going to take the data from local disks. It's about you are distributing your data in the memory itself. Okay, so it's a distributed in-memory system, or you typically call it as cluster in-memory computing system. So that's the, I would say that's one line definition about Spark. Now, the thing which makes Spark most exciting is it provides you a very high level APIs which are primarily exposed in Scala, but nevertheless the support is given to Java as well as Python also, okay? And then it has its own optimized engine which supports the general execution algorithms or general execution graphs and all. Okay, so more about it, it would become clearer when when we'll dive deep towards Spark, probably not in this class, but just to summarize it, just like in Hadoop, you have something called MapReduce, right? And then what happens there? you typically talk about, you typically focus on writing mapper and then reducer wherever it is required, right? And if it is required, then typically you go for writing your custom partitioner and all, right? But then whatever happens under the hood, how exactly the data is distributed, if you're not writing your custom partitioner, then how exactly all of the records for a given key are coming together in a specific reducer. This is something which you never worry about, right? This is something which is taken care by the framework itself. So similarly, here when it comes to it, Spark provides the high-level APIs primarily in Scala and then Java and Python as well, wherein you just write your business logic, okay? And then their execution graphs, how exactly they are going to be executed, how exactly the data is going to be stored in the memory and all that stuff is taken care by Spark framework itself. You do not have to worry about it. That's the exciting part of it. The other thing is Spark is not like other specialized big data systems. So I think I would like to give the example of Cassandra. I would like to give the example of Storm and all, which are again big data systems. But again, they are very, very focused to a specific kind of business need. When it comes to let's say it comes to Cassandra, it's all about your huge data storage and then random and fast access and read to the data, right? That's a kind of typical business scenario or typical problem statement which Cassandra is trying to solve. Now with this kind of solution, wherever it is applicable, you plug in Cassandra and then you can go with it. But is it a framework? No, it is not a framework. It is just trying to solve a specific problem, right? Can you do some sort of machine learning with Cassandra if I ask about it? No, probably you cannot, right? Because your answer, if you are aware of Cassandra, then probably you can correlate to it that you will say that question is invalid, right? Now, take it to the Storm. I don't know how many of you are aware of Storm. Storm is kind of a competitor of Spark, not really, but in a specific area, yes. Storm is a kind of tool which typically deals with the streamed data and it's kind of real-time processing. Okay, so now that is another problem statement for which Storm was developed. Again, it's a big data processing system. Yes, it is a real-time processing system. Yes, but what exactly does it do? It just processes the real-time stream of the data. Very good. Can you store the data in Storm? Your answer would be invalid question. If you are aware of Storm, you will say Storm is just a processing tool. It doesn't store the data. You have to plug in one of the databases along with it, or you have to dump your data into some sort of file system or something, right? So the point here is all of them are some specific, okay, some specific tools which are kind of a framework. It provides you a high level of APIs, it provides you high level tools and all, which take care of various things. So for example, I think more about it, I will cover these things in bit more detail in coming slides. But just to give you an idea, let's say you want to process some sort of stream of the data. Okay, stream of the data. It is like I'm talking in the terms of the Storm. The same kind of processing you can do in Spark. There is something called Spark streaming. So apart from the Spark core engine, wherein you write your program and you try to generalize your MapReduce and all, apart from that, if you want to process some sort of streamed data, right, it is possible using Spark. Use Spark streaming. Okay. Now you have some sort of structured data, and only problem with you is, or with your setup is, it is quite huge, and you do not want to use Hive because you know, right, that the time it is going to take is quite large. It is several seconds at least, right? In the order of seconds plus. Then your obvious choice is, I think in Spark world you have the answer for it. Typically it is called as Shark, but I will explain it about it a bit more detail in the coming slides. So Databricks, which is the inventor of Spark, they have stopped the development towards Shark. Now it is being replaced by another thing called Spark SQL. So again, Spark is a very fast changing world, but right now, as of now, all the support is provided to Shark. Future developments or future, I would say releases would be completely into Spark SQL. The good thing with Spark SQL is, or Shark, for all the practical purposes in the class, I will be demoing, in the course, I will be demoing Shark, and I will be demoing Spark SQL also, but since Spark SQL is still the alpha release, it is not yet integrated with Hive successfully. Okay, so the point with Shark or something is, you can integrate them with Hive, and using Spark SQL or Shark, you can run your Hive queries unmodified. Now just imagine the kind of performance gains which you are going to have, right? The same Hive queries, the same data which is there in HDFS, everything is same. Only thing is, this time you are firing them via Spark, or I would say via Shark, and you are getting the results in fractions of seconds versus 30 seconds or 45 seconds, or I don't know, several minutes, right? So that's the kind of difference. By the way, why it is called Shark? Basically it is Hive plus Spark. Sorry. So just in case if you people were wondering why these absurd names are, so at least we have some sort of kind of answer for that. Again, another important question, Mahout, right? Many of you would have attended some sort of data science course, or there is a separate Mahout course also. So Mahout is a machine learning library which typically takes the help of Hadoop framework, right? Spark has its own machine learning library, and in fact, as an update, probably entire Mahout itself is going to be moved to MLlib. MLlib is called machine learning library, is called the machine learning library package of Spark itself. So as of now, again, it is also in the development phase, but many of the algorithms have already been moved towards MLlib, and it is enriching. By every release it is enriching, right? The only difference between Mahout and MLlib is it is going to run much faster. So again, that's a kind of advantage, right? So the overall point, what I'm trying to bring here is, be it MLlib, be it Spark SQL, in fact there is something called BlinkDB, okay, which is kind of approximate database. It might be a bit new term for some of you, but yes, I will not cover much about it right now in this slide. There is a dedicated slide for it. So there are several kind of components which are there, and it is being developed more like a framework rather than a focused big data solution. That's why Spark is something which is becoming very, very popular right now. Okay, so I hope it gave you a bit of idea about what exactly is Spark, right? This discussion. Now, going to the next slide. Okay, before I proceed to the next slide, seems I'm just trying to see some question tab, or if there are any interesting questions. Is Hadoop compressing all this data which are being generated? Okay, Mukul, I think this is not really the right time to answer this question. Okay, so Srinivas, and I think there are other people also who have asked this question, that do Storm and Spark do the same thing? I hope Srinivas and others who have asked the same question, you have got the answer, right? So Spark is more generalized form. Whatever Storm does, you can get nearly the same answers using Spark streaming. I hope you got the answer, right? And there are other nice questions. Okay, please explain in-memory processing a bit more, right? Okay, So in-memory processing it's all about if you're so how do you store your data for processing? That's a question, right? If you're fetching your data which you have to process from the hard disk, then it is not the in-memory processing. You are typically fetching the data from hard disk by opening a channel to it and then reading the data, processing it, and then probably you are persisting it back, right? But when you talk about in-memory processing, it's all about you're loading the data into the memory and then fetching it. The problem with in-memory processing is you cannot really load 1 terabyte of data in a single machine in memory, right? So there are several uh, several things. But yes, when it comes to at the very high level, that's a typical difference between in-memory processing and the disk processing itself. Okay. Now, next question. Sorry, I'm just continuing towards why Spark and all. Okay. So when it comes to why Spark, Spark is something which is being developed as a framework, very good, but it is not really tied only to Hadoop. So just to give you a bit of background about it, if you want to integrate Spark with Hadoop, you can integrate it in 2 ways. You can use Hadoop as just the storage level, wherein you get high availability and other stuff, right? All those HDFS features. You can integrate Spark with Hadoop just for the storage purpose and live happily. Or you might want to generalize your MapReduce programs which you might have written in, let's say, Yarn or whatever, MapReduce version 1 or something, and then you just want to improve their performance. In that case, you will be using Hadoop as the execution engine itself, wherein your Spark programs are going to run as Yarn processes, right? So okay, there the difference is. If you want to use Hadoop as the execution engine, it is only possible using Hadoop 2.0 onwards. You cannot integrate Spark with Hadoop if the version is less than 2.0, okay? And you want to use and you want to use Hadoop as the execution engine. So that is very important thing here, okay? But again, Hadoop is not the only choice. You have Mesos, you have Spark's own cluster manager. So you want to deploy Spark to multiple nodes, you have got many solutions. Hadoop is kind of very obvious, but yes, there is Mesos, there is Spark cluster manager itself, though we would be covering only Yarn side of it because of the obvious reasons. We have already covered Hadoop. You know how to create a distributed cluster of Hadoop. Then Spark is just a matter of another software installation on all of the nodes. That's all. Okay. So you can typically go ahead with various kind of integrations with Spark, but this is not the only reason. Okay. The other advantage which you typically get with Spark is that Spark is polyglot. Polyglot means typically a framework which supports multiple languages. That's typically called as a polyglot framework. Okay, so Spark is polyglot. By default, Spark is written in Scala, by the way. If you try to build, sorry, if you try to build Spark from source, you will have to do SBT. SBT is called Scala build tool. Okay, in fact, Scala is a prerequisite also for Spark. Okay, so I think probably the latest releases of Spark have Scala inbuilt. So if you look at some really old releases, they would ask Scala as a prerequisite, but I think the later releases and all, they are getting their Scala environment inbuilt. Okay, so that just depends upon which kind of I would say which kind of version you are using. But here in Edureka, we are going to cover our Spark thing completely with Scala. We are not going with Python. We are not going with Java as of now. There are several reasons behind it. Probably you might be having some questions that why exactly we are going with Scala and all, especially those people who have attended Hadoop courses and all, and we have covered it in Java. The reason being, Spark is a very evolving framework. Many of these things are new, they are gaining traction, but yes, they are in the process of stabilization. Okay, so some of the features which might be working with with Scala readily, they might not really be working with Java. So we don't really want those kind of embarrassing situations wherein we we demonstrate something in the class, and when you go back and you try on your own, you are not able to run that, right? And it is going to be too much to take the responsibility from the Java side, from the Python side as well, that yes, whatever you are going to run is going to execute. No. So there are, these things are still evolving. So this course is going to be fairly basic, but exactly this is going to give you the enough idea about how to get started and explore on your own on Spark side. But again, the focus is going to be completely on Scala side. Okay. That I think for the obvious reasons that with Scala definitely a feature can be guaranteed that yes, if it is demonstrated and if it is running once, it will definitely run easily. And the other reason is also quite important, that Spark itself is in Scala, right? So those are some of the obvious reasons due to which our language of choice is going to be Scala. But yes, having said that, can you run your programs using Java and Python? Yes, you can. And there are many other languages which are in kind of pipeline, but not yet released. Okay, so that's another advantage. Of course, probably I would say 1 year down the line or something, definitely it would be much more stable and much more of course, seeing that. Okay, another point about Java. Typically, if you are using Java, just in case, if you happen to use Java with Spark, we typically suggest use Java 8. Don't really use Java 7. The reason being, or any version less than Java 7, it is not I would say it's not really about the technical capability side of it. It is just that your programs would be much longer as compared if you try to write in Java 7. With Java 8, your life would be easier. So just in case, to those Java programmers who still want to use it along with Spark. Now, another point, I think I talked about it a bit, Shark, which is kind of a closed project now. Okay, so you might be having a question, if it is a closed project, why have you kept it? Because this is something which is very much in use. Spark SQL is a separate project which has been started, but it is still not as capable as Shark. Okay, so for all the practical purposes, support and the latest release of Shark is there. There will not be any further more releases to Shark. Okay, so for the matter of integration with Hive, that is something which works with Shark, not yet with Spark SQL. But the good thing with Shark is the moment you integrate Shark, or you want to integrate it with Hive, your queries are going to run almost 100 times faster. We ourselves have seen that. So that is something which is amazing about it. Your MapReduce applications, certain applications, I'm not talking about all, but certain applications definitely they can run almost 100 times faster, or even 5 times, 10 times faster is something which we have anyway seen that. Okay, so those are some of the things which are going to be quite interesting about it. Other thing, it provides you powerful caching and disk persistence capabilities. So some of you might be thinking that since it's an in-memory system, is it going to put all of the data? Is this going to put all of the data into the memory? No, not really. Is it going? What if the memory is full, right? So it has something called graceful performance degradation, and so there are some, these are topics of separate discussion in detailed discussion whenever we'll have it in class. But yes, it provides you the caching as well as disk persistence capabilities. It allows you to do the interactive data analysis. This is something which is very important. Interactive data analysis. You talk about MapReduce. It's kind of a, even though you know the paradigm, it's kind of a black box. Until and unless you create your jar, until and unless you submit it to the system, right? You are not able to see what would happen at the end of a stage, right? I will take a very simple example today, and you will be able to see that it's going to be kind of interactive. You run one step, you can see the output of it. You run the another step, you can see the output of it. If you don't like it, you can modify it. And then if you want to create a separate applications about it using a SBT or something, you can go ahead and you can create your own application. This is very interesting about it. Your faster batch, something which I don't need to talk about. Iterative algorithm. Since I'm sorry, since we are dealing about dealing with the in-memory data, and there are certain, I'm not saying it fully supports iterative algorithms, but yes, it does support certain category of iterative algorithms are supported, which are not at all supported using Hadoop, right? If you have to support iterative algorithms, typically you will go towards the iterative MapReduce and all, which is a separate topic of discussion. But yes, natively they are not supported. Real-time stream processing, I just gave the example of Spark streaming, and of course all of that leads towards the faster decision making and all, of course, yes. Now, sometimes data tells about itself, right? So you can actually see this. Now, what exactly is it? It's about the commits which have happened in Spark project. You can actually see such a huge traction towards the end of 2013 to 2014. We are in mid of it, right? So this community is super active, and I think I just told about brief history of it. Though I think we in our class we are going to definitely have quite a lot detailed discussions. Okay, I think that is going to be the module number 5 or something when we are actually starting on Spark. And that point we will be comparing it with a lot of things. We will be comparing it with MapReduce, we will be comparing it with other specialized systems, and then we'll be showing how exactly it is different and what exactly are the kind of advantages which you get typically by creating the hybrids of it. Okay, so but again, due to all of those kind of possibilities, this community is quite active, and Spark has become the top level Apache project, which is kind of which happened in I think last some 3 or 4 months back itself. That's it, and it went into the incubation stage in less than 1 year back, kind of thing. Anyway, now Spark ecosystem. So again, this is going to be 10,000 feet view to you. There is this Spark core engine, which is there, which is responsible basically for executing all of your Spark or I would say all of your logic there itself. Whatever Spark program you will write, they ultimately would be executed using Spark core engine. Then, just like in Hadoop, apart from your plain vanilla MapReduce, you have your separate peg, hive, etc., which are the different wrappers. Similarly here as well, you have different wrappers. Shark, we talked about it. Spark streaming to process the stream data. MLlib for machine learning. Graphics. Now you can actually see this orange color thing, right? They are actually in the alpha or pre-alpha release, so they are not really available. Okay, they are not even available on the website. In fact, for MLlib and for MLlib as well as Spark SQL, I have not written it. I have still written it as Shark. Okay, it is clearly written that it is not yet production ready, but it is available for the testing because it is going to be production ready in probably in coming few months or something, right? Or I don't know. Probably it might be. It is just a matter of releasing the latest release of it. But yes, some of the features are already up and are available for testing. I mean, for consumption as well, right? So graphics is something which will be the kind of okay. So let's not talk about it. Let me go to the next slide. Just a sec, which will tell you about it in bit more detail. So Shark, we talked about it. Spark Streaming MLlib graphics. Typically, you must be aware of Giraffe. You must be aware of something called Neo4j and all, right? So these are some of the frameworks which are typically used for graph processing. Now, graphics is the Spark answer for it. Just for the faster distributed graph processing, you will typically go for graphics. But yes, it is not yet released. Okay. Now, another thing is Spark R. So just like you have R Hadoop, you have something called Spark R, wherein R Hadoop gives you the integration of R with Hadoop. Spark R is going to give you the integration of R with Spark. Another one is, oops, so there is a kind of spelling mistake, guys. It is actually BlinkDB. It is not BlindDB here. Okay. Oh, okay. So Igor, I think you have mentioned it as well. Thanks for mentioning it. Anyway, I also just looked at it. It's a kind of a small mistake. It is called BlinkDB, guys. Okay. BlinkDB is kind of approximate query engine. So typically those people, if you are not really aware of it, what happens is, instead of getting the exact results, you are just interested in, let's say, getting the approximate results. Okay, you just want to get some sort of feeling about what exactly are the trending things about it, right? So probably the simplest example would be you are having a lot of tweets for different kind of events. So recently, let's say we had World Cup, FIFA World Cup and all, right? So you are not really interested in seeing how many number of tweets are there for a specific topic, right? If you are getting 1 billion or okay, I mean several 2 million, some 100,000, some 523, or if it is last 523 or it is 623, does it matter to you? It doesn't matter to you. But instead of getting that exact number, if you can just get around 500,000 plus tweets, right? That is something which is good enough for you, right? So these are just one of the examples, and there are several other things, right? So kind of sampling and then querying techniques which are mixed, and BlinkDB is something which will be quite interesting to see. It will probably be released very soon, kind of thing, wherein it would be an approximate query engine. Your SQLs are going to run on a huge data set, but they will give you the approximate results, not the accurate ones, right? So something which is going to be quite exciting. So you can see there itself, right? We are still talking about the very early releases of Spark, and all of them are addressing different kinds of problem statements. So that's why I'd say this is where Spark becomes completely different from other specialized big data solutions. sorry guys. Okay, next. A bit note about Scala. So as I have already told, that all of the examples which we are going to cover, they would be covered in Scala, and we do understand that there are many people who are not from Scala background, right? And I'm quite sure if I ask for a poll, probably only 2 or 3% people would come up with the answer as yes. So for that same purpose, we have divided course in 2 parts. The first 4 modules are going to be the coverage only and only on Scala. The first one, the first module is introduction about it, introduction of Scala and the installation, and then setting up of the environment things and all. But the next 3 modules are going to be the hands-on part on Scala. The hands-on part of Scala are going to be good enough for Spark. We are not going to have a only Scala training classes. We will be learning enough Scala so that we are able to write our own Spark programs. That's it. So if you are thinking from the actors concept and all, we are not going to cover that, because they are not really required in order to work with Spark. If you will be working with the Akka or something, then typically we would go for that, right? So this is how it is, and for the remaining 4 classes, it is going to be the focus on Spark with the knowledge of Scala. So a bit about Scala. It's again, it's a general purpose programming language, yes, but it is much more concise. It is much more, I would say, elegant and type safe anyway. But many times people call it as a, improved Java thing. It supports, the good thing about it is it supports both object-oriented programming as well as functional programming paradigms. Both of the paradigms are supported. And also, it is not just that only for Spark you are going to learn it. No, many of the future big data frameworks, like, or existing ones as well, Scala, Spark, Akka, they are already there on Scala. As well as there are some web development frameworks as well, like Play and all, they are again on Scala. Okay, so I would not cover much about it when it comes to why Scala. So it's a pure object-oriented language, and everything, almost everything is an object. So there is no concept of primitives here. Okay, everything is an object, and just like you must have used Ruby or Python or something, nearly the same kind of thing is applied in Scala as well. The good thing is it supports functional programming paradigm as well. So there are two two pillars of your functional programming paradigm, right? What exactly are they? Everything is immutable, right? And functions are your first class citizens, right? So I would not I would not talk much about that, but yes, it supports both of them. That's what makes Scala as very much unique. And the good thing with Scala is you can call Java code from Scala, or vice versa. You can call Scala code from Java as well. That is what makes it all the more exciting. And of course, it is being used heavily for the development frameworks and all is something. So okay, by the way, Play is something which should not have been written here. Play is the framework in which Scala is definitely, which supports Scala definitely, but it is typically kind of, I would say, focused towards the web development, not really the big data development, kind of. Anyway, now before I move to kind of hands-on and just to show you a small demo, kind of there were some questions. So what is Akka? Akka is another framework, Shailendra. It is it's a multi-actor based framework. It is completely different paradigm altogether. Okay, so let's not deviate too much on this side. Okay, so what is the difference between BlinkDB and Shark is something which I saw from many people. So I think I'll take the latest comment. So see, Shark is all about if you are having the structured data and you want to perform some sort of exact queries. Okay, so you want to say select count star from a specific table where your primary key is something, right? And your number is 17358, right? So it would give you that count. But if you want to, now you want to do the nearly the same thing in BlinkDB, okay? And your number is quite huge. So your number might be, let's say 5835889, whatever, right? So instead of this, if it gives you 500,000 plus, nearest plus, right? That's it. So it is all about, it's the SQL, but it is approximate. It will take some samples, it will apply some sampling techniques altogether, and then it will give you the trending results, not the exact ones. Okay, so I hope kind of it just gave you some answer. There are some other questions wherein people are asking me to compare Shark and Scala. This is completely unrelated question, I would say, because Shark is nothing but it's a wrapper on the top of Spark, and the Spark itself is written in Scala. Scala is a programming language. Shark is nothing but it's a wrapper on the top of Spark core engine. I hope it makes quite clear to you people, right? Those people who have asked me this question, right? Now, can we migrate Java code to Scala or MapReduce? program seamlessly? Very interesting question. Very interesting question, I would say, by Sibashish. I would say, I mean, okay. So there are two two aspects of it here. If you have written your Java code, whatever that code you want to move to Scala, if it is in Java 8, you will find it very, very easy, because the kind of syntaxes which are supported, closures, lambdas, right, anonymous functions, right, they are not supported in Java 7 or below versions, right? So you will find a very hard time if you are trying to do it with Java 7 or below versions. But if you happen to write your programs in Java 8 which supports these features and you want to move them, let's say typically to Scala, you will find it easy, because in fact you will find the syntax also quite same in that case. Sivashish, that was a very interesting question, I would say, and I think you have got the idea about it, right? So seamlessly and all, this is subjected to the conditions, whatever I have told, right? Some more questions wherein people are saying, is it fair to say Spark and Hadoop are same thing in terms of what they can accomplish? See, system or probably some database or something, yes. But when it comes to the kind of goals which it is trying to achieve, be it from the machine learning side, be it from the Sharp side or Spark SQL side, or be it from your typical Spark core engine, wherein you are going to apply your MapReduce jobs, right? So it is trying to achieve the very same thing here, right? But in much more faster way. The implementation itself is different, right? Also, your system configurations and other things are going to be different. So no prizes for guessing it, that if you want to use the very same cluster, whatever you are using for Hadoop, if you want to use it for, let's say, Spark, and that too effectively, then your machines, right, all of your data nodes should have the higher RAM, because you're talking about in-memory processing system, right? So the cost of your RAMs for each and every machine are going to increase a bit. But what you are going to get is kind of much improved performance, right? So the cost is not going to be increased so much, but the performance is going to be manifold, right? Hemant, others, in fact others also had asked the same kind of question, right? So Vivek and others are, so I think this question is coming in different manner to me, wherein people are saying Java 7 programs or Java below version programs movable to Spark. Yes, very much movable, but your programming effort would be too much. Okay. Spark. Okay. Spark work. So does the Spark work only for the structured data? What about the unstructured data which is taken care by Hadoop? You can do the very same thing, right, Shailendra and others? So definitely you can deal with the unstructured data. See, what are you going to write? At the end of the day, you are going to write a simple Spark or a simple Scala program, or those who are from Java background, Java program, right? Even in MapReduce, how are you taking care of the unstructured data? By writing your Java programs or something, right? In the mapper side or in the reducer side, you were just probably kind of transforming your input data to something which is more friendlier, right? So all of your logic went either into the mapper side or into the reducer side, but you implemented it, right? The same thing is applicable when it comes to Scala as well. right? Challenge others, right? Okay, now I'll quickly go to, so I'll not take any further questions because of the time limitations also, right? But yes, other questions are also but welcome. Just please, remember to put your questions on our Twitter handle as well as on the Facebook page, please. Okay. How are the billing rates for Spark? Are you talking about from the project side? So this, I have still taken this question because seems like a typical project manager's question. Right. Santosh, is it from the project management side? Are you talking about this? Billing rates for Spark? Right. Uh, See, this is something which is completely dependent on your organization, I would say. As a typical, I would say, as a, you know, uh, consultant side. Okay. So from the consultant side, I would say most, you will see some of the companies which have implemented Spark and they have implemented them as POCs, or, the POC became successful, so they have put it in the production. There is, right now, there is nothing which is like a production process for Spark, which is like completely into the place. No, nothing. So for Hadoop, it has evolved over a period of time. There are established processes and other stuff. So for those kind of cases, it is easier to kind of, calculate some billing rates and all. But with Spark, things are still at the experimentation stage. Things are still at, oh, okay, there is something new which is available. There is something new which can definitely do the things in much better way. Okay, so probably it will take some time. It will take some time, but yes, whenever, probably some months, right? These rates are definitely going to be much higher, for sure. Okay. So now, coming to something which I typically like, to show you in the machine. Guys, please forgive me if the display is not so very clear to you. I tried my level best, wherein what I did is I was trying to connect it via putty and show it in a bigger font, but somehow something is wrong with my system. It is still saying, connection timed out, even if I have to kind of, restarted everything. So just please bear with me. So guys, this is my virtual machine which I have set up, and it has nothing but it has got Ubuntu virtual image. By the way, all those people who would be attending Spark course, we have created a separate VM by ourselves, which has got Spark and Scala and the related things, Yarn as well, uh, installed in it. So all you'll have to do is you'll have to just download it and then you can get started. But just at the same time, at least in the first class, and for some of the things, I would be covering the installing part also, because there are there must be some people who would like to try it on their own, on their systems, right? So for them, anyway, I would be covering the installation of Spark in the first class. But here, and it would be on the plain Ubuntu image, just like it, right? Now, uh, plain simple thing, I have installed it. So I have installed the latest version. Actually, the latest version is 1.0.2, which got released some time back. By the time I started, the, course preparation, it was 1.0.1. Okay. Now, okay. So I always keep my things ready. Guys, the first thing is you have to start, if the simplest way to get started with Spark is fire up your Spark shell. Okay, so Spark shell is kind of interactive. I was talking about interactive data analysis, right? So that is something which is available. Okay, so Scala, it will open up the Scala prompt for you, You might be wondering, it is by default, it is opening Scala prompt for us. I am from Java background. I anyway wanted to try. I don't care what Vishal says, but I want to try it by my own. You can. There are, instead of Spark shell, there is something called PySpark, and for Java, I think I've forgotten. I'll tell you about that. So you can fire up their respective shells, and they will be opening, their respective prompts for you. Okay. So for Python, this is called PySpark. The moment you will fire it up, it will open the Python prompt for you. I think for Java, I think it is not even there. You have to create your own app and then submit it. Anyway, that's why I typically don't like it. Okay. Now, coming back quickly here. So guys, the first thing which I'm trying to do is, please do not focus much from the, I would say, the syntax side. Just try to understand what exactly we are trying to achieve here. I'm just creating a val. Val is typically called a value. Okay. In Scala, there is something called var, and then there is something called val, value and variable. Typically, the difference is like constant and variable kind of thing. But for all practical purposes, I have created a kind of variable. I'm giving it the name as data, and it's actually a sequence between 1 to 10,000. I'll press enter. Okay, thankfully it is not typing everything. It just says there is a range which I have calculated, and I have created 1, 2, 3 up to, it is just saying 170 ... right? So it has created a kind of variable for us. Then I'm saying sc.parallelize. By the way, sc, what is sc? Sc is Spark context, and you can actually see this Spark context available as sc. Okay, Spark context is already available as kind of sc object to you. If you fire up your Spark shell, or even if you will fire your PySpark shell, it will be available as sc to you. But if you are writing your own application, right, typically you will not fire your jobs like this in production, right? So in the class we'll be covering how to create your own Scala project also. Definitely we'll cover about that part. But when it comes to this, it is available as an object. So I have simply said sc.parallelize. Using this, I have kind of parallelized it. So what would happen is, actually I could have specified what kind of parallelization I want, right? 2, 3, 4, 5. What exactly is the degree of parallelization I want? This time I've simply said parallelize. So by default it is going by 1. Anyway, it doesn't make sense because I'm working on a single machine right now, right? And then comes this thing. Have you noticed it? Even if I have said create something, it is created, and then I have said parallelize, it gave me a message saying that at some parallelization I have done, and then it just kept quiet. This is typically called kind of I would say lazy evaluation or lazy processing and all. Until unless you invoke something called an action, your transformations and others, they are just lazy. They would be calculated, but they would not be executed. Now, I hope from whatever background you are, from whatever programming background you are, you can easily guess what I'm trying to do. I'm trying to say dist data, which I have created earlier, I'm performing a filter operation, and in that I'm saying anything underscore is kind of star. Anything which is less than 10, just filter it out, and then I'm saying dot collect. Right, guys? I hope it is quite clear to everybody, right? So essentially this program, what it does is it creates a big collection, parallelizes it, and then it simply fires a job which calculates or which gets all of the numbers which are less than 10, right? Now, can somebody tell me in terms of MapReduce what kind of job is this? Anybody? Anybody? Guys, you are able to hear me? No, it is a simple mapper job, right? Igor, Ram, it's not a reducer job. It's a simple mapper job. right? What are you doing? You are having a data and then you are doing a filter. What is the golden rule of MapReduce? Segregation in mapper, aggregation in reducer. You're not doing any aggregation, right? So collect is something else, Apurv. For now, we can just assume that yes, it is this data.filter and I'm just performing collect operation. See this, how fast it gave the result. Anyway, the collection was quite big, right? So you can just see that it was just one simple example, but it might not be so very clear. So the first example which I showed was wherein I have created the data by myself, right? I might be having the other state wherein the data would be, let's say, from a specific file. Okay. Now readme is something, just a second guys, Ctrl+T, cd spark, clear. Now if I say ls, you can actually see there is something called readme. So if I just say cat readme and head, let's say this, you can see that, right? It's a typical readme file. I'm going to perform a simple word count on it. Okay. Now all of you have seen word count in Hadoop, right? How much time does it take? Typically it takes anything between 10 seconds to kind of 30 seconds or so, depending upon the machine configuration, right? And in the VM itself. All of you would have tried that. Now I'm going to try the very same thing. So what I'm going to do here is, in the first case, I created an val by myself. This time I'm creating it by loading the text file readme.md. Okay, enter. It has created something called, okay, there is something called RDD. We'll not talk much about it. It's called resilient distributed data sets. Okay, so we'll talk about that later. Now let me just do only this part. Let me just do only this part. Okay, it is actually your MapReduce. How long is your MapReduce in Java and how long is your MapReduce in Scala? F dot flat map L split. So whatever is written here between these are typically called Scala closures. You'll understand it when you'll understand about Scala. Okay. Then there are something, these are typically called the collection methods. Okay. Dot map, and then you are going to apply another closure within it. So these things make your typical. So it's a word count, nothing else. You can actually see this. I'm actually trying to emit word comma 1 from mapper, and on the reducer side this is quite cryptic, isn't it? Underscore plus underscore. So it's all about that. I'm just collecting all of the result and then I'm saying dot collect. If I fire it up, it gives you some result. You are not able to see that. Okay. Now instead of this, I can do multiple things with it. I can say, I can apply another method here, and I can, why am I doing this? For each, I can say print ln. See this. So I'm not going to verify it, that how many times a word came, but you can actually see this, right? How fast was it? Right? Try it once more. Isn't it much faster than your word count? The same example, the same thing, right guys? Have you seen this? Can I get some responses? right? That is one. That is one. Another thing, there is something called caching. If I have cached this result, second result, third result, fourth result, so onwards, it would be even faster. Okay, it would be even faster from that. Now, this is where I have published it, but I could have said this. I could have said this. Collect, and then let me call it. What am I doing? I'm saving the result to a file. What happened? Okay, I'm not going much into the detail of it. Save as text file is not a member of. Okay, so I might be making some of the mistakes, guys, and I don't really want to debug that right now. But yes, the point is I could have simply saved it into a file also. Okay, and it is just that it just makes the things much faster, as well as your programs much more readable and much more smaller, right? Not to mention that much easier to kind of maintain them as well, right? So this is your actually word count example. We'll discuss about it in detail if you happen to attend those classes. Definitely about the syntax, about all those things, we'll definitely talk about it. Okay, so I think yes, this was it from my side for this session. I hope it, so this was not a sales pitch kind of thing. Okay, so it was completely from the side of a bit sharing about what exactly are the capabilities of Spark, and there are some new alternatives which are now available, and they are evolving rapidly, right? So it's all about these things. I hope it has added some value. Your time, the biggest investment is all about your time. So I hope it has added some value by that time, right? And thanks again for attending the session. And definitely, so Srinivas, what I can do is you can just drop your query there, and I can definitely share those Java programs. It is, but I will be sharing it with Java 8. The thing is, I have not yet kept it ready with me. Srinivas, I hope you understand that, right? Definitely. Now, point about these programs or these, sorry, this recording, is this going to be available? All those slides and all, they are going to be available on our Edureka blog. Definitely. Okay. Great. Srinivas, so I have not forgotten it. You can drop the mail. In fact, you can say that Vishal has told that he will share it with me. I will share it with you. Srinivas. Okay. Great. Thank you, guys. Thanks for attending it. And yeah, I think our next batch is day after tomorrow probably, right? Right. So hopefully see you, some of you there. Okay, bye. Logging off now. Do provide your feedback, guys. It's important.